Good morning, everyone. It's Mrs. Corajanis. Your decimals activity today, the first slide is just a review of the exponent properties from yesterday. So just as a review, we had the negative exponent property, which said, let's say I have change my color here. A raised to the power of negative 3. We want to rewrite that with a positive exponent. So I'm going to rewrite it as A raised to the power of negative 3 divided by 1. And then the base and the exponent are going to go to the opposite side. So it's going to be A raised to the positive 3, because once it goes to the denominator, the exponent becomes positive, and then we need our placeholder as 1. And yesterday we saw the pattern on why this happens, okay? If I have 1 divided by, let's say, c raised to the power of negative 4, and I want to rewrite this power as with a positive exponent, then what I'm going to do is I'm going to take c raised to the power of negative 4, I'm going to put it in the numerator. So I'm going to get c raised to the power of negative 4 divided by 1. But then I can simplify that more and get c raised to the power of 4. Okay? So that was one of the properties that we used yesterday. The other property was the zero exponent property. And what that one said is if I have any base raised to the power of 0, that equals 1. And you can try that with any number in your calculator. If you put a variable in your calculator, it doesn't work, but you can put any number. So if I have 3 raised to the power of 0, that equals 1. If I have negative 423, but the negative is in parentheses, raised to the power of 0, that's 1. Okay? If I have negative 423 raised to the power of 0 and the negative is outside of the parentheses, then that's negative 1. If I have a raised to the power of 0, that's 1. All right, so now these get a little bit more complicated today. So let's say I have negative 2 times negative 1 raised to the power of 0 times y raised to the power of 2, all divided by x raised to the power of negative 5. So that's the first one right here. We're going to do these one at a time. So negative 2 has an exponent of 1, so we can write that 1 there. So that has a positive exponent. So we're not going to do anything with that one. So that base with that exponent, we're just going to rewrite. So it's just going to be negative 2. Then negative 1 raised to the power of 0, that equals 1. So that's going to be times 1. And then times y squared, because the y squared has a positive exponent. So y squared. Okay. Then x raised to the power of negative 5, that has a negative exponent, and we want to rewrite it with a positive exponent. So we're going to put that to the numerator. So x raised to the power of 5. Because once we switch sides, the exponent becomes positive. Now we need to simplify. So negative 2 times 1 is negative 2. And then we get x raised to the power of 5 times y raised to the power of 2. Actually, I think we have to have it the other way. I think it's from, let me see. Oh, okay, that works. Let me see if I put it in the other way, if that works. No, so I put it in alphabetical order. X comes before Y. X raised to the power of 5, Y raised to the power of 2. Okay, so you get the idea of how to do these. All right, let's do one more together. So let's do the second one, and then the rest you can do on your own. So I get negative 3 raised to the power of 0 times y raised to the power of negative 5 times z raised to the power of 3, all divided by x raised to the power of negative 2. So let's start with negative 3 raised to the power of 0. So that's 1. So I'm just going to write the 1 times. And then y raised to the power of negative 5, that has a negative exponent. So we're going to rewrite that power with a positive exponent, put it in the denominator. So y raised to the power of 5. And then z raised to the power of 3 has a positive exponent. And then x raised to the power of negative 2 is a negative exponent. We want to put that one to the numerator. So times x raised to the power of 2. Then remember that 1 times anything is whatever the anything is. So we can rewrite it without the 1. So I get z raised to the power of 3. Oh, we want x first. X raised to the power of 2 times z raised to the power of 3 divided by y raised to the power of 5. And that should be right. Let's see. So you can, try these. So x and then shift 6 raised to the power of 2. And then the right arrow key to get that back down. Z raised to the power of 3. Okay. And then in order to put it in a fraction, because you have a lot, put it in parentheses. And then do your fraction bar. There you go. And then y shift 6, 5. Okay, I know this might take you a minute to get used to it, but that's okay. All right. So you can pause the video now and finish number 3 and 4 on your own or with Mr. Duggan. All right. So let's go to today's lesson. And here we are. So exponent properties. So yesterday we did the zero product or the zero exponent property. We did this one. And the negative exponent property, we did this one. Today we're going to do the product of powers property. And that is a raised to the power of m times a raised to the power of n is equal to a raised to the power of m plus n. And I'll explain that more in the next few slides. And then we're also going to work with the quotient of powers property. So a raised to the power of m divided by a raised to the power of n is equal to a raised to the power of m minus n. Okay, and a lot of these are going to be trial and error, okay? Because I'm not going to do every single one of them with you. All right, let's go to the next slide. So let me rewrite this. Pause the video. I'll be right back. All right, I'm back. Okay, so I get a raised to the power of m times a raised to the power of n. So I'm multiplying powers. So my power is a raised to the power of m, and my other power is a raised to the power of n. So since both of these powers have the same base, I'm going to add the exponents. So I'm going to have a raised to the power of m plus n. Okay, the reason is let's say I have a raised to the power of 2 times a raised to the power of 3. This says that I'm going to add the exponent. So I'm going to get a raised to the power of 2 plus 3. me show you why that works. A raised to the power of 2 means that I am going to have a times a. So I'm cloning the a twice. And then a raised to the power of 3 means I'm cloning the a 3 times. Well, how many a's do I have? 1, 2, 3, 4, 5. So a raised to the power of 5, which is the same thing if I added the exponents. 2 plus 3 is 5. So I get a raised to the power of 5. So write that down. So you can pause the video now and write that down if you didn't write it down already. So that's the reason why we add the exponents. So let's try this one. Use the product of powers property to simplify a raised to the power of 7 times a raised to the power of 11. So I'm just going to add the exponents. So a raised to the power of 7 plus 11 is equal to a raised to the power of 18. And that's it. And you need to show this work, please. Okay, so I get a shift 6 raised to the power of 18. There you go. It tells me nice job. Now let's go to the next slide, see what's happening. All right, same thing here. We're going to use the product of powers property. I have c raised to the power of negative 2 times c raised to the power of 10. So I'm just going to add the exponents. So I'm going to get c raised to the power of negative 2 plus 10, which gives me c raised to the power of 8. Let's see if I'm right. C raised to the power of 8. Yes. All right. So make sure you're copying this work, please. Okay, these might get a little bit more complicated. So I'll do these for you, and then you're going to do the rest of the product of power slides by yourself. So I have negative 7 times a raised to the power of 4 times b raised to the power of 2 times 3 times a raised to the power of 5 times b raised to the power of 6. Now, what's cool about multiplication is that I can move things around. Like in the numerator, like all these would be in a numerator, or I can move things around like all in the denominator, and I'm still going to get the same answer. It's the commutative property of multiplication. So in other words, if I rewrite this as, this is the same as rewriting it so everything's kind of in order. So I'll write the numbers kind of in order. And all of these mean that they're being multiplied, right? So negative 7 times a raised to the power of 4 times b raised to the power of 2 times 3 times a raised to the power of 5 times b raised to the power of 6, even though there's no multiplication symbols in between. So I'm going to rewrite this, and I'm going to move things around. So I'm going to get negative 7 times 3, and then times a raised to the power of 4 times a raised to the power of 5 times b raised to the power of 2 times b raised to the power of 6. Now, I told you when I multiply powers with the same base, I add the exponents. But like negative 7 times 3, they don't have the same base. And I'm not going to undo what your second grade teacher taught you. They taught you how to multiply. So negative 7 times 3, I'm still going to do what your second grade teacher did. So negative 7 times 3 is still negative 21. But then I'm going to add the exponents when I'm multiplying a raised to the power of 4 times a raised to the power of 5 is a raised to the power of 4 plus 5, and then b raised to the power of 2 plus 6. And then I'll simplify. So negative 21a raised to the power of 9 times b, 6, 7, 8, raised to the power of 8. So let's see. So negative 21a, shift 6, 9. And then you got to make sure that you do the right arrow key, b raised to the power of 8. Let's see if I'm right. Yes. All right, I'm going to erase this one and then go ahead and copy it down. Pause it if you need more time. All right, so this one is negative 6x raised to the power of 4 times y times 5x times y squared. These mean the same thing. This is still all multiplication. And we can still use the same thing we did in the previous one where we moved things around. The only thing I want to tell you about this one is that add those understood ones as exponents with your variables. So y has an understood exponent of 1 and x has an understood exponent of 1. So I'm going to rewrite this. So negative 6. Oh, I don't like the red. Hold on. Okay. So negative 6 times x. Oh, no. Times 5. Times 5. Times x raised to the power of 4 times x raised to the power of 1 times y raised to the power of 1 times y raised to the power of 2. Now I'm going to multiply. Remember, I'm not going to undo what your second grade teacher taught you. So negative 6 times 5 is still negative 30. And then x raised to the power of 4 plus 1, because when I multiply powers with the same base, I add the exponents. And y raised to the power of 1 plus 2. So negative 30 times x raised to the power of 5 times y raised to the power of 3. All right, let's see. So negative 30 x raised to the power of 5. Make sure you do the right arrow key. Y shows 6 raised to the power of 3. Check my answer. Beautiful. All right, I have to do you can do this one on your own, this one on your own, this one on your own. Okay, really quick. I'm going to do the quotient of product powers property, and then you can practice these. You might not get to this. So if I have a raised to the power of m divided by a raised to the power of n, I'm going to subtract the exponent. So a raised to the power of m minus n. So when I multiply powers with the same base, I add the exponents. When I divide powers with the same base, I subtract the exponents. Okay, so let's say I have a raised to the power of 10 divided by a raised to the power of 2. I'm going to subtract the exponents. So I get a raised to the power of 10 minus 2. Okay, which gives me a raised to the power of 8. Maybe I should have used smaller numbers. That's okay. So what this means is I have 10 a's, 3, 4, 5, 6, 7, 8, 9, 10, and I divide it by 2 a's, a times a. Well, then if I divide it, 8 divided by 8, and I think I said times, but that's divided. 8 divided by a is 1, so those cross out. 8 divided by a is 1, so those cross out, leaving us with 8 a's, I believe. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Yep, and that's our answer. All right, let's try this one. So 10 times y raised to the power of 10 divided by negative, and add that understood 1 right there. Negative 1 times y raised to the power of 3. All right, so now what we're going to do, 10 divided by negative 1. Again, I'm not changing what your teachers in second grade taught you. So 10 divided by negative 1 is still negative 10. So that's going to be negative 10. And then the y's are going to be y raised to the power of 10 minus 3. So I get negative 10y raised to the power of 7. So negative 10y raised to the power of 7. Check my answer. Yes. All right, so let's do the next one. So z raised to the power of 100 divided by z raised to the power of 30. Okay. When I divide powers with the same base, I subtract the exponent. So I get 100 minus 30. So I get z raised to the power of 70. Let's see. Yes. All right, let's see the next one. And then, all right, so these are the same things. Let me do this one for you. So 11 raised to the power of 9 divided by k. Okay, if I have these ones as understood ones in front of the k, and they understood 1 as the exponent. I do my numbers first. I'm not going to reteach what your second grade teacher taught you. 11 divided by 1 is still 11. And then k raised to the power of 9 minus 1. So 11 times k raised to the power of 8. So you need to be writing these down as well. So 11 times k raised to the power of 8. All right. Let's do the last one. So m raised to the power of 80 divided by m raised to the power of 80. Okay. When I divide powers at the same base, I subtract the exponent. So I get m raised to the power of 80 minus 80. So 80 minus 80 is 0. M raised to the power of 0 is what? What property did we learn yesterday? M raised to the power of 0 is 1. All right, let's see. 1. Beautiful. All right, you can finish the rest on your own.